Welcome back to the Additive Snack podcast. I'm your host, Fabian Allerfeld, and in today's episode, we promise an exciting deep dive into a groundbreaking area, enhancing athlete safety through additive manufacturing. Whether it's a helmet, a knee pad, or even the shoes on a player's feet, the sports equipment of tomorrow is being revolutionized today. Joining me to unravel the intricacies of this fascinating subject is none other than Scott Peeland, a distinguished professor at the University of Southern Mississippi. Scott is an expert at the intersection of sports and technology and has been on the front lines of research and development, discovering how additive manufacturing is sculpting the future of player safety devices and other crucial equipment. Welcome, Scott, and thank you for being on Additive Snack. Scott, you're a clinician by training, but now you're one of the leading figures in sports technology. That must have been quite the journey. How did that look like?
A torturous path, I think, is the best way to describe it. I sold shoes when I was in high school, like a lot of high schoolers do, to make side money. Yeah. And I absolutely just loved. I was a shoe guy in the early 90s. Like, that's the shoes we go on and recreate and makes lots and lots of money in the shoe world right now. Exactly. So Jordan, all the greats, all these shoes are coming out. And I met a guy. Nike had a technical program called an Econ Tech program, and which is Nike spelled backwards. And they would come to your store and they would give you the technology background. They weren't salespeople. They weren't telling you how to push the shoe. They were talking about what were the Max Ruby patents, what is this pressurized air system, and how does it work. And I just was really intrigued by that. And I like to draw, and so I was like, you know what, I'm going to go be a shoe designer. And then, for some reason, I never took any identifiable path to achieve that. Just life happened, and when I was supposed to go right, I went left. And it was just it's been an interesting journey. I ended up in school to become an athletic trainer. So an athletic trainer, for those who don't know, are the people that you see running out onto the field when there's an injury. And an athletic trainer is provided with, they have really one major goal, and that's to prevent injury from taking place. So create an environment that is conducive to safety for the athlete, for the physically active. So I graduated from Valdosta State University in a small town of Valdosta, Georgia, as an athletic trainer, and then I went right up to UNC Chapel Hill to get my master's in athletic training and exercise science. And I wanted to be a clinician. I really enjoyed watching people go from an injured state to a healthy state, or go from a healthy state to a healthier state. And there's a huge return on investment when you invest in people. And I like the clinical interactivity and being creative. And athletic trainers are known just to be creatives. You need a pad, we can make a pad. And you just try to use what you have, whether it's duct tape, a 9-iron, and a Brillo pad to make it happen. You can try to make it happen. So that's the aspect of athletic training that I really liked. I worked for 2 years as a high school clinician and met my beautiful wife, and then we went off to do grad school. But while I was working at the high school level, this is mid to late 90s, I really quickly realized that there was not any tools in the clinical tool belt related to the brain injury of concussion. In fact, when I was at UNC Chapel Hill, Kevin Guskiewicz was one of my advisors. He's now the chancellor of Chapel Hill. But he's one of the leading individuals on the forefront of concussion, of the brain injury. And so that's where I was exposed to it. And when I was acting as an athletic trainer at high school in Georgia, I was one of the only athletic trainers in the entire state that was actually implementing a concussion protocol. Wow. And that's not that long ago. I'd love to tell you that I'm really young, but I'm 50. But still, that's within not too distant of a time. Yeah. So we've come a long way. But as I was sitting on the field and implementing athletic training protocols, I noticed really quickly that a lot of people didn't understand what it was, rightfully. And there was a huge need for education. And there was an even greater need for diagnostic tool sets that people needed to be able to employ to give them power to make the right decision to withhold athletes if they needed to. So I went back to University of Georgia, where I did my PhD, and that was in exercise science. And I focused on concussion, but on the clinical side. So coming up with symptomatology checklist and scales that could measure and diagnose the concussion.
Okay.
I came to University of Southern Mississippi as my first job, fully intentionally mindset, I'm going to continue my line of doing clinical research. And for some reason, in 2004, I really couldn't find a population of athletes to actually do my studies on. Mm-hmm. And so when you're doing clinical research and you don't have access to athletes to do clinical research, you've got to back up and punt.
Okay.
So I had a colleague that I met. He was also starting out, also an athletic trainer, exercise scientist. And we were thinking we wanted to go get some large grant dollars because that's what the brochure and the PhD tells you, right? You go into academia, you need to go get some pretty substantial funding. And so that's what we had our mindset on. So we went through an entire list of some of the largest or most successful grant writers in the university. And we found a guy by the name of Charlie Hoyle. Charlie Hoyle was a polymer scientist. And so we walked and knocked on his door and asked him to mentor us in grant writing. And probably, I would say, the next 3 years was more like a postdoc in polymer chemistry, polymer engineering, material development, and understanding the massive importance and the huge gap missing when you want to think about the human material interface. Mm-hmm. And that's really where I started to get connected into having a better working understanding of materials, but also opening up doors to finally do what I thought I wanted to do when I was selling shoes back in 1991. And that was to collaborate with multidisciplinary teams to come up with product solutions that have a positive societal impact, which is really a fun thing to be able to do. And that's what I do now.
Yeah, and now you are a professor and the director of the School of Kinesiology and Nutrition at the University of Southern Mississippi. And like you just explained, you have a breadth of knowledge from the clinician side all the way to chemistry and material properties. And I'm very curious to understand the role that additive manufacturing can play in the field of kinesiology. And maybe do me a favor in explaining what kinesiology actually is.
So kinesi and ology, right? So study of human movement. Mm-hmm. And so it's an umbrella term, just like sports medicine is an umbrella term. So there's many things that fall underneath that as a descriptor. And so when you think of kinesiology, you're also thinking of exercise science. You're thinking of the disciplines of exercise physiology. You're thinking about biomechanics. You're thinking about coaching, management. The degrees that we have offer things like cardiac wellness. If you're going to go and you're going to help somebody recover from a heart attack, it's a great springboard field to jump into things like physical therapy, occupational therapy, athletic training, physician, medical doctor, all of that. So it's the foundational information on how the human body functions physiologically, biomechanically, and even emotionally, because we even do sport coaching, which would encompass sports psychology, exercise psychology. So it's a pretty broad field, so you need one really cool looking word that explains it, and that's kinesiology. Okay. And then the nutrition side is we have a program that prepares people to become registered dietitians. And so we combine those and we take the strengths of both aspects to prepare our students as they move forward. Years ago, we actually began to partner with the University of Southern Mississippi has a polymer science and engineering program, which is pretty elite and just a great group of colleagues to work with. And we partnered with them on several years ago in actually advising students that wanted to do more sports technology related fields so you can have access to those. Mm-hmm. And so we had a PhD program that we fostered individuals through, and they really left our program with the full breadth of knowledge, PhD level knowledge of exercise science, kinesiology, and a full level and depth of knowledge on the polymer side. And a lot of those folks are active in industry right now. Yeah. And they're doing really great things. And as time has gone by, when we finally started to be successful in grant writing, the conduit for which we were able to do that is understanding how to mitigate blunt impact in helmets and doing that for the Department of Defense and the U.S. Army. And so I have a lab, and we can take anything that is worn in sport or tactically and we can assess it in our lab. So monorail drop towers, pneumatic impactors, twin wire drop towers, high-speed cameras, concomitant ATDs, anthropometric testing devices. And so now we've been doing that for about 8 years. And we've done everything from create blunt impact mitigating liner systems for advanced combat helmets, all the way to consulting with companies to do soft shell helmets, to full-size football helmets, looking at baseball, lacrosse, women's lacrosse, potentially in helmets, and have consulted with different firms from everything from ideation all the way up to implementation. And so that has been a terrific vehicle for us to gain a better understanding of additive and really the robustness of what additive brings to the table. I think I can probably sum up linking that chasm that exists between saying I'm an athletic trainer. You never really put those in the mix. Yeah. And I do kinesiology, so you don't really put that into the mix. But what we really found is when we first started around 2014 in looking at what was available off the shelf to actually try to prevent concussion, you're looking at systems that were using very simplified foam systems, vinyl nitrile foam typically, which works great. But it's a pretty old technology. And even in 2006, when you started to see quote-unquote advancements being made to mitigate concussion, the only thing you really saw was you saw helmets, shells getting larger, right? So in 2005, 2006, Riddell Revolution came out with a 40% larger space. So you're pushing more foam in there, which is that's a first step for sure. And so what we began to realize with our polymer friends is the first limiting factor is going to be a lack of novel materials to do what you need them to do. And you are working within a very limited design space. You've got variables that come into play that are hard to control. You've got design cycles that are very quick. And you've got an almost impossible injury you're trying to prevent that's almost impossible to measure, to find efficacy. And so it's a very difficult problem to solve. We feel like if you were going to see an advancement in actually mitigating the injury, you have to have the creation of novel materials. And where that is happening, or has the greatest opportunity to happen, is in additive.
Okay.
And that's what gets us pretty excited. Is we started working on with Dr. Hoyle before he passed away. We were working on thylene acrylate systems. They're perfectly cross-linked. They've got amazing mechanical properties. And so that was our exposure. The dean of our school at the time, or our college at the time, had a career as a dentist. And so as young junior faculty working our way up, we were like, let's make mouth guards. Let's 3D print mouth guards. And that was in 2006. And that's what we were aiming to do. Wrote a couple of papers on the materials, and that advanced into, and Dr. Hoyle died, that advanced into looking for other people to collaborate with, which transferred over into energy mitigating systems for helmets. And so that's the pretty long-winded answer.
That helps a lot. Thank you for that. And you just mentioned that previously the answer to preventing concussions is larger shells and more foam. And we see that in other industries too, because we're limited in our thinking and we're limited in the design space that we're working with. How is additive manufacturing changing that whole design space, and how does it allow designers of sports equipment to think differently on preventing injuries such as concussions?
Great question. And I think if I'm thinking about something, let's think about a different type of injury, really. If I tear my ACL, that's my anterior cruciate ligament in my knee. That knee's a fairly responsible ligament in your knee. You need that. It holds your knee together. It prevents your tibia from sliding forward on your femur, and it's a pretty common injury that we see. But it's a ligament. And I can tell you just by putting my hands on a knee and doing a special test, I can image it. I can tell you exactly how much of that ligament is torn, to what degree there's laxity. I can quantify that very easily. And if I have that and I want to prevent that, I can tell you how much force is required to rupture that. All these things. I have all these quantifiable known variables that I can give to a multifaceted team of designers and thinkers, engineers, materials people, and I can say, okay, here's the design parameters. Now find something to prevent that from happening. Unfortunately, with concussion is, even if you think about this, you can go into Google Scholar, you can go to MedSci, and you can plot out how many scientific papers are produced on concussion every year, and you can just plot that out, starting in maybe 1975. And so you had maybe one or two papers come out. Generali came out around then, defining what it was, and then you see a handful, if any, papers coming out each year. And so there's not many dots on that line. As soon as you get to the late 90s, you start to have the recognition that you could actually implement, test, and quantify some of the injury rates in athletes, because then it became an identifiable injury there. And then it just exponentially grows. So in the early 2000s, 2003, when I published my first paper, if I remember correctly, I think there were like 25 total papers published on concussion, sport-related concussion that year.
Wow.
Now you're in thousands each year. So it just exponentially grew. And so even in 2023, when we're looking at concussion, we've made some terrific advancements. But the number one thing I think that we've learned is that it is a ridiculously difficult problem to solve. And so you spent 5,000 years thinking that it was a linear injury, which means a linear injury would be like if I had a glass of water that had a cube of ice in it, and I started to slide it pretty quickly. Then you would have the glass move, the water move, but you would have that ice that kind of lags behind it, and then it tinks up against the glass against your hand. And so that's linear. But if I now incorporate another idea of rotation, where I'm not sliding the glass along the table, I'm actually hitting it down to up, and I'm spilling it. The water flies out the top, and the ice cube flies out of the top of it. That's rotational force. And so concussion is a combination of both of those. And we don't really have a firm grasp on quantifying, one, how to measure that in a human. There's been some really smart people and some real innovation that's occurred in trying to discover those numbers. But there's not a real quantifiable threshold that's dependable and consistent. And it's just hard to measure. And so when you're talking about designing to solve a problem, you're not giving this hard, fast, understandable, quantifiable injury to overcome. You're learning about the injury in the real time that people are trying to solve the problem. And so I think it's really easy to look at industry for a lot of us and go, man, they just really haven't done a whole lot except for marketing. But the reality is the problem is that difficult to solve, and anything towards that end is a positive step, I think. And so the first feasible step, when you saw this massive rise in a need and an understanding of the injury, a need for a solution, then you start to see that helmet's getting a little bit larger, but you use what you have available to you. Then you see people start to think outside the box and say, okay, thin-walled collapsible structures, or they use that in car crashes, and so let's apply that. Let's make it out of a TPU. And so companies like Schutt started to make TPU collapsible structures in their helmets, which is an innovative step. Then you had Zenith helmet manufacturer comes on the market, and they have a pretty innovative approach, and they have a TPU structure that is a mechanical structure that has a hole in it, so when it compresses, the air pressure builds and escapes through the hole. And you're looking at an actual change to the force time curve, which is cool. But all of them rely upon traditional manufacturing methods. And all of them come with a cost. Weight may be a cost. Thermoregulation, which is another huge issue in sport. You kind of have to kick that to the curb a little bit and say, I'm worried about putting as much foam or TPU in there as I can to try to mitigate this nebulous concussion, but I'm also now increasing another problem. Where additive comes into play is, I think, the design freedom for people to think outside of the box, to be able to try to design towards the things that we absolutely know, whereas it's rotation and linear, while also considering things like thermoregulation. That's where additive is going to not only blossom, and we've already seen products hit the market now that are addressing that, but they're going to increase things like fit. You're going to be able to eventually be able to control your weight and put weight in different parts of the helmet that it might be beneficial to, just like you think perimeter weighting in a golf club. So you might be able to do that within a helmet. And then just having a greater design freedom for different types of structures that we're not even aware of yet. Additive allows you to do that. And it allows you to do that on a time scale that doesn't necessarily require you to go out and think of the design, then go do the tooling, spend a lot of money and time on tooling, get the prototype, realize, ooh, that was wrong, and then go find more money to do more tooling. And by that time, you've got 6 months to 8 months have passed. The turnaround cycle for idea on napkin to CAD to an actual prototype is phenomenal. And I think we're only on the very beginning of understanding the true power of that. There's a lot of garage tinkerers out there, and there's a lot of athletic trainers around the United States who have good ideas, and folks like athletic trainers who are in the fray, who are sitting in the garage going, I really wish I could make this happen. But Additive now provides them an avenue to potentially be able to do that. And I think when you do that, you're going to have some pretty innovative ideas that start to float to the top. So it's a pretty exciting time, I think, because of the things that open up through Additive.
Yeah, I couldn't agree more. And what I think is really interesting that we can elaborate on a bit more is you have these garage tinkerers who may have really interesting ideas, and Additive allows them to bring those into the market. But you also have a lot of sports fans in industries such as space who use Additive on a daily basis, in automotive, in the traditional medical industry, where we see a lot of hip implants and now moving into knee implants that are being 3D printed. Do you see an influence from these outside industries pushing into, let's say, helmets by using additive manufacturing as that catalyst?
Yeah, and I think this brings up, to me, it's a very sad circumstance that I think we're overcoming. And I actually think Additive might be the vehicle that allows this to fully come to realization. So when I first started, I remember very clearly, Dr. Hoyle was going to take my colleague and I, and he wanted to introduce us to the polymer faculty. So we brought a football helmet with us, and it was not painted. It was just polycarbonate, typical shell, and it had stickers all over it, just award stickers, name stickers, all over it. So I bring this in, and it's the first time many of them have ever even held a football helmet. And the first question that comes up, it's a great question. First question comes up, goes, wait a minute, these adhesives have solvents in them, and that's attacking the polycarbonate. So what do they do about that? Or what do you do about UV light? You're playing with these, and they're not protected. They don't have a paint coating on them or anything. And we know, because I've seen my headlights on my car, that UV breaks down polycarbonate. What are they doing about that? At the time, this is a long time ago, the lifespan of a helmet was really unlimited. And even now, it's about 10 years. And so you're thinking my headlights on my car start to fog up after about 5. And so this similar material is being stored in a hot place. It's not being regulated. High school athletes or athletes at all range may get mad and toss it up against a locker. And when we start thinking about how these things are treated and what their life cycle is, and then how do you even design them, one of the things that we started to notice is that there was a massive disconnect between, and I'll just use these potential fields as just examples, but your engineers, your polymer science, your chemist, your physicist, your industrial designers, your clinicians. Massive gaps of information because they all may have coming up with their own independent solution, but nobody was talking. And when nobody talks, you silo. And when you silo, you don't get innovation. And so really where we found our benefit, coming from the field of athletic, the profession of athletic training, where if I'm on a sideline on a Friday night and someone's injured, I've got to be able to have a cogent, articulate conversation with the physician. And I've got to speak at that level. And then I've got to turn around and I've got to articulate what's going on with Junior to a parent who may only have a 3rd grade education. And so what we saw is we took those skill sets and we applied them in the research team and started forming multidisciplinary research teams, and we became the communicators. And so we started to learn how chemists speak and how physicists speak. They're all saying the same thing, but it's all very different if you're just siloed thinking. And then pulling individuals together into a room, and then you start to create. And so you have a tremendous amount of innovation that's taking place in space, aeronautics, in automotive, and you're only now starting to see those groups start to share collaborate and apply some of those lessons learned a long time. You can look at the literature and you can see moments in time where the wheel is literally being recreated by a different group who think they're being innovative, but the reality is that was done 10 years ago in automotive. I really think, and what I've seen is, because additive has a quicker turnaround and overall has some lower cost on some fronts, I think that it opens up conversations and opportunities for different groups to talk about it and collaborate. So we definitely see the influence, especially at this point in time, you're starting to see moving up to scale, and complete manufacturing of a deliverable product becomes within the visible scope of doable. Mm-hmm. That's happening now, and I think that opens up other opportunities where you're thinking, okay, I can either do this, or now I can implement 5 steps of a design on that, but that is only allowed through additive. Additive is reachable, attainable, now I can do it, and it opens up a pretty big side of that conversation.
Totally. And let me dive a little bit deeper into that last point that you made, which is we're just at the beginning of the influence that additive manufacturing can have on sports technology. And from your perspective, because you've been in that industry from the beginning, you've seen additive slowly creep into that sector. What are the long-term impacts of that technology on different products, on sub-industries, but also on the athletes and users out there that use these technologies on a daily basis?
I think that can probably be summed up in something that is fairly new. I think there's about 2 companies that are out there right now. Back in the day, when an athletic trainer needed a bubble pad. So a bubble pad is just a simple piece of plastic that you raise it up over wherever the injury is, and that way the pad itself, it's almost like putting a donut over an injury site. So let's say you have an AC separation, which if you take your hand and place it over your shoulder, your middle finger is directly over your AC. Let's say that's where the pain is. And so I want to put a pad on that I can still hit somebody underneath the shoulder pad, but I want to distribute that energy across a broader surface area. So the way athletic trainers used to do that is you would take a piece of orthoplast, which is typically used for like orthotics, dip it into the hydroculator, which is makes warm, wet therapy, get it to about 130 degrees, it would become malleable, and then you mold that to the shoulder, and you make a bubble pad. Now, because we can now simply take our phones and scan the area and become specific to that individual, and then you can 3D print that pad. And there's companies now that you just send them the scan, they'll make it and send it to you. You can even scale it to as you have maybe injury recovery, like cast, knee braces, anything. So as the body changes over time with that rehabilitation, you now have the adaptability to adapt and change that pad or that prophylactic to match the shape of that individual person and do it in a cost-effective manner. And plus, you're dealing with materials that are intended to function within those environments. You're not just making something that was made for something else and applying it and hope it works. Even in things like simple things, like if you have a casted athlete, like they have an arm cast. And so most state sporting groups will mandate that you have to pad that cast. And so what you end up doing is you go try to find as much 1/4-inch pads you can find, and you tape it and you make this big club of a hand, and it's aggravating and it's not necessarily clean, and there's some just things about it that aren't that great. But now you could easily scan that cast, make a 3D printed pad, put it on there, it's clean. You're not going to worry about staff because you can clean it. And there's just a lot of small things. I foresee a time where athletic training rooms will have 3D printers within. I foresee a time where maybe even have one in your home and you can scan and pull from a litany of things, and orthopods are able to sit there and go, this is what you need. And I think that is an aspect that is truly exciting, because if you can get person-specific prophylactic, you can get better protection. You can get something that changes, just braces, and looking at mouth guards and how mouth guards can, the Invisalign type products where you're looking at that they change with how your dentition changes. You can probably do the same thing with bracing. And that aspect, I think, is going to have a massive impact on how we think about injury prevention, and how we think about keeping people active for a longer period of time, which is a huge thing that we need to be thinking about. Healthier people are happier people, and exercise is medicine. So the more active we can keep individuals, the higher quality of life that they can have, better societal impact they can have, and and they can get out and interact and have fun and do sport.
What a perfect ending to an episode. Happier people and healthier people. That is the true impact that additive manufacturing should achieve. So, Scott, I want to thank you for being on Additive Snack, and it was great having you on the show.
Fabian, I am absolutely humbled to be a part of it. I appreciate the podcast. I think you do a fantastic job in it. You've had some absolutely stellar individuals. I wish you luck in the future of the podcast, and like I said, I'm just humbled to be on it, and hopefully it's entertaining and educational.
Thanks so much.